Now that we have a pretty good handle on creating multipliers out of percentage problems, let's try question number 7 in the most efficient way possible, which is to read the question, strategically turn everything that we can into a geometric equation, and use the equations to do the work for us instead of tables and long, complicated calculations. If we read the question, we'll see that there are two types of sandwiches that she's going to deal with, the chicken and the tuna. Each type seems to have its own percentage multiplier. The chicken is going to increase by 2%, so I want to make sure that I notice that word increase, because remember from question number 6, that dictates whether we're going to add or subtract to our initial 100%. And the tuna salad is going to decrease, which again dictates my choice of what to do when I turn that information into a multiplier. So let's start in letter A by thinking about each type separately. We know that anything that has to do with percentage growth is going to be a geometric sequence. That is something that you can assume is a universal truth, that anytime you deal with percentage, it's going to be a multiplier, which means it's going to be geometric. So I'll format this like every other geometric sequence. T of n equals. The initial value is going to be 165 because they told us she's starting with 165 sandwiches of each type in the day of the debut. And then our multiplier is going to be based on how this chicken situation grows. So increase by 2%. I'll just do a little bit of side work here. That means I'll start with 100% of the sandwiches plus 2% more. So that, if I do that quick addition, would be 102%. Then we know we have to move the decimal 2 places to the left, which means 1.02 is my multiplier to the power of n. You can probably start to do this sort of thing in your head. You probably will get to the point where you can just look at increase of 2% and know that it's 1.02 without having to show this little scratch work, but that's of course personal preference, and you can decide for yourself if it's worth it. Same thing goes with the tuna salad sandwich. We have T of n equals, it does say that 165 is the initial value of each type, so I'll keep that 165, times, we are decreasing by 1%, so that means 100% of the sandwiches sold, minus, because we're decreasing, 1%. 100 minus 1 is 99%. Change that to a decimal becomes 0.99 as our multiplier to the power of n. Now that we know exactly how to use our equations, we can answer questions B and C. Questions B and C are basically just asking you to use your equations to be able to figure out the details. So I'm going to leave that as an exercise to you, not necessarily because you need any more information. I don't think me doing this in the video is going to change anything for you. You know what you need to do now. Plug into the equation the relevant number for n that represents 1 week. Just pay attention, because notice n represents how many days this percentage has been growing by or decreasing by. So if n is measuring in days, but question letter B is asking about a week, you'll just have to remind yourself how many days would n be counting for there. Letter C is kind of an experimental question. I'm not too committed to you doing letter C. If you want to skip it just in favor of moving on to other things, it would be fine to skip letter C. Ordinarily, that's the kind of question we would do in class with the graphing calculator, because the graphing calculator has a few nifty features like the table that make question letter C a lot easier. And to be fair, if you don't have a graphing calculator, it's not really worth doing this question. So it's fine if you skip it. But question number 8, kind of similar. Question number 8 is essentially the reverse of number 7. It's giving you an equation that's already been done, and it's asking you what exactly was the percentage. They didn't tell us the percentage the way they did number 7. So what was the percentage that they were using for which 0.88 came out as its multiplier? So hopefully that all makes sense. Hopefully you've had some time to chew on the idea of a percent multiplier, because we will use those ideas further in the next few lessons. I want to make sure you have a solid foundation.